Yow, zombies. Zombies again. I'm going to try to keep this video under 10 minutes, so here I go real fast. Outbreak, 3 different campuses. That's one of your IVs, right? Location, San Francisco, Los Angeles, San Diego. IV. Another IV if they had sufficient training or not, right? Yes or no, 2 levels. Last IV is gender. So you got gender, training, location. Those are your IVs. Your DVs are their fighting skills, scored from 0 to 30. 30, your Chuck Norris. Yeah. The number of missions you go on and the number of confirmed kills. Okay, those are all your DVs. It kind of makes sense to put them together because it measures a person's zombie slayerness. Okay. And then other information that was collected was their age and their anger scores, right? 0 being they were completely at peace, and 50 they were as angry as a person can get. I can't think of something funny there. But here we go. Didn't scare you, did it? So here's the data. Okay, I'm going to cut and paste this into a SPSS. Please hold. Location, IV, gender, IV, age, suspected covariate, training, fighting scores. Okay, so just make sure that your IVs are nominal, your DVs are scale. I'm just going to check the location one real quick, make sure I did it right. So yes, 1, 2, 3, San Fran, Los Angeles. Okay, so we're good to go. So let's check assumption number 1 of our Mancova. Sample size. Okay, so since we got 3 DVs, I took the IV with the largest number of levels. So that's our location one. So there has to be a minimum of 3 per cell here, right? So 3 times 9 is 27. We have 30, so we did not violate assumption number 1. Assumption number 2, normality. Let's go ahead and check the normality of the DVs. Analyze the descriptives. Explore. And we just want the DVs. So that's our fighting skills, zombie kills, number of missions, statistics. Don't care about that. Plots. We want our histogram and we want our normality. Plots with tests. That's where you get your Smirnoff test of normality, you guys. Options. Don't care. Click OK. Remember, we're only looking for normality here, so there's how many in each group. There's the means of each of the DVs. Normality, here we go. So the normality has not been violated for any of the DVs. Here's the Smirnoff test. Continuing. So normality is okay. Next check is outliers. That's where we're going to do the Mahalanobis. Please hold. Remember with the Mahalanobis, we need to make a fake DV, and we're going to just call it ID. Back to the variable view. We're just going to call it ID. And it's going to be a scaled number. And we're going to make everybody just a number. 1 through, go to variable view. Go to data view. So IV is just going to be 1, 2, 3, 4, 5, all the way down. Please hold. Make sure I did that right. And good. Okay, so outlier test. We're going to go to analyze regression, even though it's not a regression. Linear. Our dependent variable is going to be the one we just created, the ID. Our independent variables, strictly for this test, are going to be our DVs. So that is fighting skills, zombie kills, number of missions. What do we want? We want none of that. Plots. Nah, we're not gonna do that right now. Save. There it is. Mahalanobis. Clicking continue. Click OK. So remember, with the regression box, we're only looking at this box, the residual statistics. We're going to get a maximum Mahalanobis distance, and it looks like 8.295. So now we're going to look up what our critical Mahalanobis distance is in our spreadsheet. Hold on. Here it is. I'm going to open it. Please hold. Okay, again, this is on our website. So N is the number of sample size. We have 30. K is the number of IVs. We got 3. Hit enter. Boom. So there's our critical value of 15.131. Let's make sure we did not go over that. And we did not. So in other words, there's no outliers that are going to affect this Mancova. Remember that outliers can seriously affect a Manova or a Mancova. So number 3 is good. Thank you, Mr. Mahalanobis. All right, assumption number 4, linearity. That's the one where we use the scatter matrix graph. Here we go. Graphs, legacy, scatter. We're going for the matrix this time. Define it. So our matrix variables are our DVs. So what do we have? We have fighting scores, zombie kills, number of missions, and we can only do one IV at a time. So I'm just going to do location first. Click OK. Okay, so here's our matrix graph. So this is the first DV, second DV, third DV. And these are the 3 different levels of the IVs. Some of these don't look great, but close enough. You could kind of see a best fit line that would go in there somewhere. So we got to repeat this with the other IVs. Just going to go back to our matrix scatter. We're going to change the location out. Let's put gender in. Click OK, get a new graph. And so here's the new graph with gender, same thing, right? DV1, DV2, DV3, same thing. I can kind of see a straight line in here. This one's kind of questionable, but no biggie. So let's do the third one. By the third one, I mean the third IV. Matrix, define, out with gender, in with the training or not. Click the OK, get a new graph. Okay, so here's the training or not, okay. Again, they all look pretty good to me, so I don't think we violated the assumption of linearity. Okay, so let's move on. Homogeneity of regression. Now, this is different than homogeneity of regression slopes, okay? That has to do with covariates, but at this step, homogeneity of regression only matters if you're putting the DVs in some kind of order of importance, and we're not, okay? So we're just going to go ahead and skip that one. And then our next one is multicollinearity and singularity. I always start with the singularity first. That means if we're going to lump together all the DVs, and we did not do that, okay? So remember, if you only got one DV, you're not going to run a Mancova. You're simply going to run an Ancova. So we did not sum up the DVs. Multicollinearity, though, is if your DVs are too strongly correlated. So let's go ahead and take a look at that by going to Analyze, Correlate, Bivariate. And we're just going to stick our DVs in there. Okay, so it's fighting, zombie kills, zombie mission, click OK. Okay, so here's our correlation box. So remember, they can be correlated up to 0.8 without violating this assumption. So fighting skills with zombie kills, not greater than 0.08. I'm sorry, 0.8, not greater than 0.8. So we did not violate the multicollinearity as well. Here's the last assumption from the Manova column. It's the homogeneity of the variance-covariance matrices. We have to actually run the Mancova to get the box's M test. So we're going to come back to this one. Right, the box's M test is going to tell us about this after we run the Manova. So now we're going to address the covariate assumptions. First of all is assumption number 1, measurement of the covariate. Right, we're going to check for age and the anger score. We already collected the data. It wasn't in the original analysis, so that part's okay. Right, it was recorded beforehand. Assumption number 2 for covariates, reliability of the covariate. We're assuming, of course, that they did measure this right. So there's not a lot we can do about that. We just assume it, okay? Number 3, the correlation of the covariates have to be less than 0.8. So we're not 100% sure that age and anger score are covariates, but let's go ahead and check that out real quick. We would simply go to Analyze, Correlate, Bivariate, clear these guys out. So we're trying to see if the covariates of anger and age are strongly correlated. And they are not. In fact, they're negatively correlated, okay? So we did not violate that assumption. Covariate assumption number 4, linearity. So that's between the covariates and the DV. You know what I think we're going to do? We're going to go ahead and run the Mann-Cova to identify what is a covariate and what is not. I'm not going to do this test unless I know that either age or anger score is a covariate, okay? So let's just go ahead and run the Mann-Cova now. We're going to try something a little different. I want to just run a Mann-Cova first without the covariates. So analyze, general, multi. Our DVs are fighting, zombie kills, number of zombie mission are fixed, our location, gender, sufficient, okay? Again, this is just a regular Mann-Cova with no covariates because I'm going to try to see the difference between the two. Okay, model, don't care. Plots, you know, that'll show if there's interaction or not, but we'll be able to tell that from the tables. Okay, so anything under post hoc? No, post hoc. Save. Nope, nothing there. Options. Like always, we need the descriptives, effect size, power, and homogeneity of variance. Continue. So again, this is without covariates, so this isn't really a Mann-Cova yet. So how many in each group? Mean, standard deviations. Box M, not violated. So that is homogeneity of covariance variance matrix. Multivariate tests. So this is where it lumps all the DVs together. And I'm going to look at the interactions first. So no three-way interaction, no gender training, no location training, no location gender. In fact, there's no interaction at all with the regular Mann-Cova, okay? So this could change once we start throwing in covariates. So let's look at the main effects of gender. No significant difference. Training, there was a significant difference. And let's pull location down here. Oh, location, there was a significant difference as well. So there was as it stands right now with no covariates, there was a significant difference in zombie slayerness depending on which campus they were in and whether they had sufficient training or not. Okay, so that was practice. So now we're going to rerun this with the covariates. Okay, general linear model. Everything should be pretty much the same once we go in. But I'm going to put in anger and age. Everything is preset. So now I'm going to click OK. And it's going to tell me if either or both of those are actually covariates to the point where they're affecting the DV. Okay, so same general linear model. Number in each group means our box test is still the same. We did not violate it. Okay, so we don't look at the intercept. So anger score. What do you know? This tells me that anger was in fact a covariate. It's affecting all three DVs. Age. Age was not a covariate. It was not affecting all three DVs. So with location, we still have a significant difference between the three different campuses. Gender, do not have a difference in gender. We do have a significant difference in training. And we do have interaction now that we have added a covariate, okay? So you'll notice here that there is an interaction between location and training. So it means one of the campuses must be training their people either better or worse. And we do have a significant interaction in gender and training. So it means that either the males or the females are getting better training, but there is no three-way interaction between location, gender, and training. Okay, so that tells me that age is not a covariate, but anger score is. So for the last thing I'm going to do is I'm going to rerun it with just the anger score as a covariate. General linear model, multivariate, right? So I'm going to kick out age because I know it's not a covariate. And I'm going to click OK. And this is going to be my final. Okay, so this is our Mancoba with anger scores as a covariate. Same. Right, I'm just going down to the important boxes. So the box M test is still the same. We did not violate that. And anger score is a strong covariate. There is a significant difference in location. There is not a significant difference in gender. You notice that? There is in training, okay? But there is no interaction between location and gender. This is the official call, okay? No interaction between location and gender. There was between location and training, so that means one of the campuses is training their survivors either better or worse. And there was a significant difference between the genders being trained, okay? And there was no overall interaction. So make sure that the homogeneity of variances haven't been violated, and we'll notice that one of the DVs, yes, the number of missions is not, the variance between that is not normal. So we have violated one of the DVs, homogeneity variance, but I don't think that's such a big deal, so we're going to keep going. So here's our ANOVA box. Again, because we know we got interaction all over the place, we have to be careful. Look, anger scores. It is not a covariate for fighting skill scores. It is not a covariate for number of zombie kills, but it is for the number of missions. Okay, so anger seems to predict or affect the number of missions a person goes on. Now, location. There is a significant difference in location between all three. Gender. There is only on the number of missions. Okay? Sufficient training. There is a significant difference between the fighting skill scores and the number of zombie kills, depending if they've had sufficient training or not. And let's look at the interactions again. Get rid of that stupid double click thing. Okay, here's your interactions. You do have an interaction on the fighting skill scores and the number of missions, but not zombie kills. That's between location and training. So gender and training, no significant interaction. Last one is the three-way, and there is no significant three-way. So in a nutshell, the anger was only a covariate for the number of missions. So in a nutshell, anger score was the only covariate for the number of missions. There was a significant difference in the number of all three of the DVs for location. There was not in gender except for the number of missions. There was a significant difference in the number of fighting skill scores and the number of zombie kills, depending if they've had sufficient training or not. And there was no interaction between gender and location. There was interaction for location and training strictly at the fighting skill score. And gender and training, there was no significant difference there, and there was no three-way interaction between location, gender, and sufficient training. Okay, we ran our Mancoba. We know that the only covariate is anger scores. So I'm going to check the other assumptions, linearity first, and it was the homogeneity of regression slope second. But I'm going to go ahead and check the linearity between the covariates and the DVs at each of the IV levels. They should form some kind of linear relationship, right? Instead of curvilinear, that's what we're doing. So we're going to go to graphs, legacy, scatter, and there's going to be a bunch of them, but this one you pick simple, define it. Okay, your DV is your covariate, and we got 3 of them, so let's just do fighting skills. Your x-axis is your covariate. Your set markers are by your IVs, and then you click OK. So we're going to have to do that about 1,000,000 times. I'm just going to go real fast and skip a lot of this stuff. But this should pull up a yuck. So here's fighting skills. You can tell right off the bat, this doesn't look very linear to me. I'm going to double click. Okay, I'm going to put a trend line in there. And it's not very strong. Okay, you're going to take the square root of that, but take the square root of that, it's going to come out to be about 0.4. So I guess that's okay. So let's do them all like that real quick. Next one. I'm just going to do all the IVs at one at a time and then switch. Gender. Okay. Again, putting the trend line in there. What do you know? It's the same thing. So that's pretty much the same thing. So I'm assuming that most of these are going to do it. I'm going to do a couple more. I don't want this video to run forever, but it went way over my 10-minute limit. One more. This time I'm going to change the DV to zombie kills. And then I'm going to get rid of the gender, put a location. Location has 3, right? Click OK. Looks pretty much the same to me. So this one isn't very good as well. So it looks like we might have violated the linearity between the covariate and the DVs at the different IV levels. But again, we're just going to say it's robust. And then let me go to the last assumption. Okay, linearity has not been violated between the covariates and the DVs. Okay, so the last one is the homogeneity of regression slopes. So this is a little bit different than the homogeneity of regression from the MANOVA. This is actually talking about the slopes of the covariate with the DVs at each level of the IV. This actually is a build upon from the last thing we did here. Hold on. So we're going to go to graphs, legacy. And again, I'm going to cut this short because this video is getting way too long. I am. So I'm just going to check the DV of zombie kills, covariate of age, and location. Click OK. I need a new graph because I'm going to double click it. And I'm going to hit this subgroup. Right? We do not want crossing. Crossing is interaction. And we have it all over the place. So it looks like we have violated the last assumption, the homogeneity of regression slopes. I'm just going to double check it with another one real quick. I'm going to switch something around. Oh, I'm sorry. That is for the number of zombie kills. So let me switch that DV with number of missions. See what happens. Okay, double click. Remember, we do not want crossing. Subgroup. Oh my gosh, we got it all over the place. So 2 out of 3. Let me check the last one. The last DV, that is. And if we violated it with one of the IVs, we don't need to look at the other IVs, I'm pretty sure. So switching out number of missions to fighting score. Hiya! Click OK. Bring up the new one, double click. Hit your subgroups. Crossing all over the place. Okay, so we definitely violated the homogeneity of regression slopes. But again, I'm going to invoke the rule of robustness. And we're going to continue. So we violated the last assumption. Oh well, nobody's perfect. And that is it for our MANCOVA. That was a long one. And it's been a fun teaching experience for me, and I hope you guys enjoyed it as well. MGZ, out.